I'm going to put it here on the floor. I'm going to take my shoes off. And let's see how much I weigh with the scale on the floor, as it is right now. And I have it set for pounds. So as I step on it, it reads, 196.6 pounds. Can you go around the other side and try and get that? 196.6 pounds. Okay. Now this scale also reads in kilograms. But kilograms is not a weight, it is a mass. I just gotta wait for this thing to zero out. I'm going to change it to kilograms. I think it's set. Nope, still pounds. OST. Kilograms. So I weigh 196.6 pounds. That is proper sentence along with the units for the number. I've got to wait for it to zero out again. These are digital electronic things. So I'm going to stand on this and use those same words, that same sentence. And it says, I weigh 89.2 kilograms. The scale isn't giving me my weight. What is it giving me? My mass. There's some electronics in here. It's taking my weight, dividing it by 9.8, and giving me kilograms. The sentence remains the same. I weigh so much, but the actual result is the mass. I'm going to change this back to pounds. I have here a textbook. Normally I bring a 2x4, or I have a special plate that I made for this demonstration, but for today I'm going to bring in this book. Here's The Great Mathematicians, small textbook. In the center of this is Isaac Newton. I have Einstein up there and a few others. The Great Mathematicians. What I'm going to do, so everybody can see, right now the scale as I had it is completely horizontal and perpendicular, straight up and down. I'm going to put it on an incline like this, using this textbook. It's just something that I can add it to just to give it a small incline. Let's see what happens with my weight on an incline. Ready? All right. I'm over here, I need a shoulder. Not as steady as I once was, you know. So before I weighed 196.6, if I recall. Now I weigh, I'm a little shaky here on this, about 193. It's shaking up and down as I wobble. 193 pounds. What happens is when you're completely up and down, everything's horizontal, this is giving you your weight. When you put it on an angle like this or an incline, it's actually measuring your normal force. So your scale doesn't measure your weight, it measures your normal force. I'm going to do some examples of what a normal force is and how to do those calculations. So as long as your scale that you're stepping on is completely horizontal, like so, okay, flat and going straight up and down, your weight is equal to your normal force. Once this is on an incline, the normal force is different than your weight. Your weight hasn't changed. It's still straight down towards the center of the earth, but the normal force is a little bit different. That's what this scale is actually measuring, not your actual weight, but your normal force. Unless it is in this configuration, then, well, you can argue weight, normal force, back and forth.